This video will help with your Chapter 16 Mastering Physics assignment, and it has to do with sound intensity and decibels. So we've already seen that the sound intensity is given the symbol I, and that's in watts per square meter. Now there's a wide range of intensities that occur for just our everyday lives. So the threshold of hearing, so this is the minimum intensity that we can hear. It depends on the frequency. That's at about 1,000 hertz, and we are quite sensitive to the frequency. We don't tend to have as good a hearing at lower frequencies. But this threshold of hearing has an intensity of 10 to the minus 12 watts per square meter. So we can just hear a sound wave if that was its intensity. The threshold of pain, on the other hand, and so if it's a really loud sound and it really hurts our ears, goes all the way up to 1 watt per square meter. That's 12 orders of magnitude, 12 powers of 10. So that's an enormous range. And because of that huge range, we like to define a logarithmic scale that would go, in this case, from 0 to 12. So this logarithmic scale is called the sound intensity level. And sometimes people get confused. Sound intensity is not the same as sound intensity level, or sometimes just called sound level. And these are what decibels are all about. And so beta is the sound intensity level. So this gets SIL. Beta is the sound intensity level in decibels. And the equation on your equation sheet is that the sound intensity level is defined to be 10 times the log to base 10 of the intensity of the sound over I naught, where I naught is defined to be that threshold of hearing. So I naught is a constant. So you always use 1 times 10 to the negative 12 for I naught in that equation. So that is constant. Okay, so a couple of examples. If we wanted to work out what the sound intensity level is for your threshold of hearing, then we would put in 10 to the minus 12 over 10 to the minus 12. And the log of 1 is 0. So this is 0 decibels. dB is decibels. So clearly that's why the 10 to minus 12 is there. So our threshold of hearing is 0. The threshold of pain is 10 log 1 over 10 to the minus 12, which is 120 decibels. So that's very painful. Over about 90 decibels, you'd want to wear earplugs. A normal conversation is about 50 to 60 decibels. A jet engine, which would certainly damage our ears if we were standing beside it, is about 150 decibels. Okay, so some of the problems that you're going to encounter using these equations. First of all, you should remember your log rules. Do you remember that the log of A times B is equal to the log of A plus the log of B? That's very handy. Also, log of A divided by B, even more handy in most of our examples, is log A minus log B. And then one more log rule that you should remember is the log of A to the N is N log A. Okay, so those are going to be very handy. You need to know those log rules. Something else you need to know, remember that the intensity of a sound wave is equal to its power over area. And so in this case, we'll use capital P for power. Now the area, you're going to assume that our sources of sound spread out, the sound spreads out in spherical areas. And so this area is 4 pi r squared, where r is the distance out to the sphere. And then this, so that might be R1, this might be R2. So clearly, the further you get away from the source, R3, the lower the intensity, and it goes as 1 over R squared. Now, when we're doing these problems where we're walking away from sources, the power of the source is going to stay constant. Okay, so P is the power of the source, and that's not going to change. All we're going to do is we're going to walk away from them and see what happens to the intensity. And we're going to walk away from them and see what happens to the decibel level, the beta number. Okay, so let's do a couple of examples of how we're going to use that. So example 1, and these will be exactly like the problems you encounter in your assignment. So it will be what happens to sound intensity level, the beta number, to sound intensity level, i.e. beta, when intensity, that's just capital I, increases by a factor of 100. Okay, so what this means is we have this I2 is 100 times I1. So clearly you've gotten closer. You've actually gotten 10 times closer, but that's okay. You're given this. So you're given that I2 is 100 I1. The question is, what is the relationship between beta 1 and beta 2? Now, what we do here is we subtract. And we'll see why we do that. So just put in the numbers. It's 10 log I2 over I0. That's the definition of beta 2, minus 10 log I1 over I0. That's the definition of beta 1. And now we're going to use our log rules. This is 10 log A minus log B. So that's log A over B. Okay, so there's the log rules. And then the I0s cancel. So this is just the log of I2 over I1. So notice how the intensities, you have a ratio here. The betas, you have a difference. And so now we can put in whatever the factor between I2 and I1 is. In this case, it's 100. The log of 100 is 2. And so this is 20 decibels. So by increasing intensity by a factor of 100, you increase sound intensity level by 20 decibels. So the difference between beta 1 and beta 2 is 20 decibels. Okay, so that's example 1. Example 2 is if you move 100 times further away from the sound, what happens to the decibels? Okay, so what happens to the sound intensity level, i.e. decibels, if you move 100 times further away from the source? Now remember that the power of the source doesn't change, just the intensity does, because you're moving away and you have more area that sound has to pass through. So I1 is the power over 4 pi R1 squared, that's how far away you are. I2 is the power 4 pi R2 squared. And we're told that R2 is 100 times further than R1. Remember, power stays constant. So we can get this ratio, I2 is to I1, as P over 4 pi R2 squared is to P over 4 pi R1 squared. And we see that this is just the ratio of the radii flipped and squared. So if you move further away, the intensity goes down. So notice how it's I2 over I1, but here it's our R1 over R2. Okay, so we can use the expression from the last example, the difference in the sound intensity levels is 10 log R1 sorry, I2 over I1. And so it's 10 log R1 over R2 squared. Use that rule. Log of A to the N is N log A. So bring the 2 down. We've got 20 log R1 over R2. And so it's 20 log 1 over 100. And the log of 1 over 100 is -2. So this is equal to -40 decibels. And so this sound intensity level has decreased by 40 decibels, which you would expect because you've moved further away. So decreased by 40 decibels. Okay, so I think that's probably enough for this video.